Welcome back to Bright STEM Tutorials, the home of clear structured mathematics for every student who wants to truly understand numbers and not just memorize them. I am Luther Hussein Pamba, your tutor. Okay, today we are going to cover evaluating limits algebraically. So I grab your pen, open a notebook, and let's get into it. By the end of this lesson, you should be able to evaluate limits using the three major algebraic techniques in evaluating the limits, which is number one is the direct substitution, number two is factoring method, number three is rationalizing. So we are going to start with the number one technique, which is the direct substitution method. Technique one, which is a direct substitution. If f of x is continuous at x is equals to a, simply plug in the value of x with a. For our instance here, the limit of a function x squared plus 3x minus 1 over x as it approaches 4 is equals to, as we have said, we just plug in the value of x, which is the value of x here with the a. In our case, a is 4, so we are going to plug it with 4. So it will be 4 squared plus 3 into bracket 4 minus 1, which will give you 24. So, for instance, if you get any equation for evaluating the limits, you should always use this direct substitution first. If you get a real number, that is it. But if you get an indeterminate number, then you have got to move to the second technique, which is the technique called factoring. So in our case here, in this example, we've got a limit of a function x squared minus 9 all over x minus 3 of x as it approaches 3. So the first step is to try and use the direct substitution method. And if you use the direct substitution method, for instance, if we put here a 3 squared minus 9, that will be 0. And 3 minus 3, that will be 0. So 0 over 0 is indeterminate. So we move now. We will have to move to the to use the second technique, which is factoring. So how do we go about it? So we have got to factor the numerator, which is x squared minus 9. It will be x squared plus 3 all over x minus 3 from the quadratic equations. So if we cancel this and this, we will remain with the x plus 3. So after the next step is substituting 3 with the value of x, which is 3 plus 3, which is equals to 6. Another example is here. We've got a second example, which is finding a limit of a function x squared plus 5x plus 6 all over x plus 2 over limit of this function as x approaches to negative 2. So here we'll just have got to factor the numerator using the quadratic equation from this quadratic equation to which will be x plus 2 into bracket x plus 3 all over x plus 2. So this x plus 2 will cancel with this x plus 2. We'll have x plus 3. So if we substitute this x with the value of a, which is negative 2, we'll get a negative 2 plus 3. And our answer will be 1. The third technique is using the rationalizing method. So, for instance, this method is used when you have square roots in the equation. So this is an example. Limit of a function into square root of x plus 4 minus 2 all over x of x as it approaches 0. So if we substitute x with 0, definitely we get an indeterminate value. So in our case, we'll have to multiply the numerator and denominator and the denominator by the conjugate, and the conjugate of this is the square root of x plus 4 plus 2. So after multiplying it, we'll get x plus 4 minus 4 all over x into bracket the conjugate, which is the square root of x plus 4 plus 2. If we open the brackets, or if we factor out, this 4 minus 4 will be 0. So it will be x all over x minus all over x into bracket the square root of x plus 4 plus 2. So this x and this x will cancel, and our answer will be 1 all over the square root, all over the square root of x plus 4 plus 2. So if you substitute x with 0, we will get that 1 all over the square root of 4 plus 2, which will be 1 all over 4. And this is the summary table that will help you solve any limit equations. This brings us to the end of this video. Before you go, don't forget to drop any comment. And if this video helped you understand the topic better, please give it a thumbs up, like it. It helps more students find this channel. If you are new here to this channel, kindly subscribe and hit the notification bell so you never miss a lesson. We always upload every day. Thank you.